Matt Roscoe here at the University of Montana. I lecture on Chapter 8, Section 3 of our text on divisibility test in our course Higher Math for Elementary School Teachers at the University of Montana. Okay, we're going to talk about the divisibility test for 2, 5, and 10. I'll mention those briefly because we've already talked about the justification for the divisibility test for 2, and the justification for 5 and 10 is similar. We won't go over the reason why those tests work. We will spend some time talking about the divisibility test for 3 and why it works and applying it. And then we'll go ahead and just state and apply the divisibility test for 9 and 4 and let you think about why each of those tests work from an explaining it standpoint. So the divisibility test for 2, of course, is this: any counting number is divisible by 2 if and only if the units digit's divisible by 2. That is, the units digit is a 0, 2, 4, 6, or 8. And the divisibility test for 5 is similar. It's any counting number is divisible by 5 if and only if the units digit's divisible by 5. That is, the units digit is a 0 or a 5. And finally, for 10, any counting number is divisible by 10 if and only if the units digit is divisible by 10. That is, the units digit is a 0. So let's go ahead and spend some time thinking about these questions by applying, I shouldn't say thinking about these questions, but applying these tests to a set of numbers. So I have this worksheet made up to accompany the lecture. You're welcome to pause at this time and to try the divisibility test for 2, 5, and 10 on each of these numbers. So go ahead and pause if you'd like and complete these columns in the worksheet, and then I'll go ahead and work them through. Okay, so to test to see if this number is divisible by 2, all I need to do is look at the units digit and ask, is it a 0, 2, 4, 6, or 8? That is the units digit divisible by 2? And of course, in this case it is, in this case it's not. For 372 it is, because 2 is divisible by 2. 480 is, because 0 is divisible by 2. 578 is divisible by 2 because 8 is divisible by 2. Neither of these. This one would be 16. 16 would, because 2 divides 6. Not 21, 25, 3200 is is divisible by 2 because 0 is divisible by 2. 4 is divisible by 2. 0 is divisible by 2. 4 is divisible by 2. So really it comes down to checking whether the units digit is even or odd, right? So anytime I have an even units digit, I have a number that's divisible by 2. Okay, so let's go on and talk about divisibility by 5. So a counting number is divisible by 5 if and only if the units digit is divisible by 5. That is, the units digit can be either a 0 or a 5. So when I go through the list of numbers, the first candidate that's divisible by 5 is 480. The next one's 545, 695, 2125, 3200, 12,345, 51,110, 959,595. Okay, so it looks like I get 4 numbers divisible by 5 in the list. And the last test that we're going to try right now is divisibility by 10. So we say a number is divisible by 10 if the units digit is a 0. So here we would have 480. Here we'd have 3200. Here we'd have 51,110. And I think that's it. One thing I think is worth noticing is that the only time we really get something that's divisible by 10 is if it's also divisible by 5 and 2. Do you notice that? So in other words, if the number is divisible by 5 and divisible by 2, it appears that that implies that it's divisible by 10, because in every case where I get divisibility by 10, I have divisibility by 2 and 5. So that somewhat makes sense to you, because 10 itself is 2 times 5. So if a number is divisible by 10, it's automatically divisible by 2 and 5. Now the converse isn't true, or excuse me, I should say that that it's an exclusive thing, that if you're divisible by 2, you're not necessarily divisible by 10. And if you're divisible by 5, you're not necessarily divisible by 10. So you can't have one or the other exclusively. You have to have both of them in order to be divisible by 10. Okay, so let's go on now and talk a little bit about the divisibility test for 3. This might be a new one for some of you. I find that some people are exposed to this and some are not in this course when I've taught it in the past. Any counting number is divisible by 3 if and only if the sum of the digits is divisible by 3. So the sum of the digits is divisible by 3. Okay, so let's take a look at applying this, and then we'll take some time to think about why the divisibility test works. So let's take this this first number, 234, and sum the digits. So 2 plus 3 is 5. 5 plus 4 is 9. So over here I'm going to write sum 9. So if the sum is 9, and I look at that sum, the way the divisibility test proceeds is it asks whether or not 3 divides the sum. So if the sum of the digits is divisible by 3, which it is in this case, then the number is divisible by 3. So that means 234 must be a multiple of 3. And a quick check here, 234 divided by 3, indeed it's 78. So it seems like that worked. Let's try this again. 7 plus 3 is 10, plus 2 is 12. So now the sum is 12, and 12 is divisible by 3. So 237 should be divisible by 3, and indeed it is. It's 79. 372, 7, 8, 9, 10, 11, 12. Again, a sum of 12. So that means that this one, the sum is divisible by 3, so the number should be divisible by 3. So if I take 372, divide by 3, I get 124. Divides evenly. Let's see, 480. Again, the sum is 12, so again it's divisible by 3. 545 has a sum of 14. Now 14 is not a multiple of 3, so it's not divisible by 3, which means that the number 545 is not divisible by 3. So let's just check it. 545 divide by 3, and indeed you can see that I get some sort of a decimal remainder, a decimal fraction I should say, when I divide it by 3. So this one is not divisible by 3, and we can proceed now by just finding all of these sums. 20 is not. Let's see, so this is going to be 20 again, and it's not. 777 is 21, and 21 is divisible by 3, so this one should be divisible by 3. It is divisible by 3. 888 is 24, and so again that's divisible by 3. I don't know if you get the gist of why I put these two here, but it turns out any 3-digit number with 3 repeated digits is going to be divisible by 3 because you're simply multiplying the number times 3 to find the sum of the digits. So that's kind of an interesting fact. This one, of course, has a sum of 3, so it will be divisible by 3. And that's also an interesting one to think about. Any number that has 3 ones in it, and any number of zeros interspersed between those ones will be divisible by 3. Let's see, 1,616, so it'd be 7. Twice 7 is 14. So no, that one will not be divisible by 3. 2,125, when I sum the digits I get 7, 8, 9, 10. So if a sum of 10 means that thing is not divisible by 3. Let's see, this has a sum of 5, so it's not divisible by 3. 5 is 10, so it's not divisible by 3. 5304, 8 plus 4 is 12, so it is divisible by 3. 8787, so what do I get? I get 15 and 15, 30. 30 is divisible by 3. 5 plus 4 is 9. 10 plus 5, 15. 15 is divisible by 3. So 12,345 is divisible by 3. Let's see, 9, 10, 11, 17, plus 22 plus 6 is 28. I get as my sum. Is that right? Let's see, 9 and 9 is 18, 18. Oh no, it's 26. Sorry. Well, regardless, it's not divisible by 3, so the number's not divisible by 3. 5, 6, 7, 8, that number will not be divisible by 3, but this one will have to be 9, so it will be divisible by 3. Let's see, this is 9 times 3, or 27, which is, of course, divisible by 3. Let's see, if I add 14, 14, I get 28. So 37, 38, 39, 40, 41. I get a 41 as my sum of digits here, which is not a multiple of 3, so the number is not divisible by 3. But this one will be 42, since it's just one digit more. And that is divisible by 3, so the number is divisible by 3. And here again I get 3, and so that number is divisible by 3. This one, of course, related to that one right there. Okay, so it looks like I get these numbers that are divisible by 3. And I hope that you're at least curious. We could check some of these, but I will guarantee that any one of these numbers, if I've done the sum correctly, is indeed divisible by 3. And if the sum is not a multiple of 3, then the number itself is not a multiple of 3. So kind of a curious area, and the question, of course, that we as teachers of this content might be really concerned with asking is why? I mean, why does this thing work? What is the mathematical machinery that's at play that makes this strange algorithm give us a quick way to check if a number is divisible by 3? So let's spend some time thinking about that. I made another handout that you can copy off if you like from the section here about this. So if we were in class, I would hand out the base 10 blocks, but we're not, so we'll use a handout to do this. Recall that a quantity is divisible by 3 only when it can be divided into groups of 3 with none left over. So explain why the divisibility test for 3 is valid by thinking about the number 258 as 200 plus 50 plus 8, or using base 10 blocks. So I'll go back to the overhead, and I'll use this base 10 block depiction of 258. So just to make sure that we're all together on this, of course, this is the 200, right, which we can think of as 2 100s. This is the 50, which we can think of as not 2 50s, but 5 10s. And of course, this is the 8, which we can think of as 8 1s in our place value representation. So of course, the number can be thought of as this, right? So what are we thinking about? Well, we're thinking about groups of size 3, and one way to see this really quickly is to just think about, well, here's one group of size 3 right there in that corner. And I see that's not showing up really well on, so I'm going to switch over. Well, maybe I'll just leave it, and I'll scan it in. But there's another group of size 3 right there, and another group of size 3 right there. And in fact, if I just sort of filled in this whole bottom row of height 3, then I think we could argue that that's an even number of groups of size 3. In fact, it's 10 groups of size 3. And so we could go right above it and do the same thing. We could say, well, there's another 10 groups of size 3 that are in that region right there. And there's another group of 10, or I guess another series of 10 groups of size 3 right here. And then things get a little bit interesting, So I guess what we have here is we have 3 times 10 times 10 times 10. So we've got 30, 60, 90, which of course isn't even multiple of 3. But if we go up above, I think what I notice is that now I have to sort of count individual groups. I get one group of size 3 right here. And then I would get another group of size 3 right here. And then I finally get a last group of size 3 right here. And what I notice is that there is exactly one left over, that purple one right there, when I count groups of size 3 in 100. And maybe this makes sense to you because if you think about 99, which is 100 minus the 1, 99 is a number that's evenly divisible by 3. So I guess what I'm trying to get across is that anytime I take a 100 block and I divide it by 3 or section it into groups of size 3, I'm always going to have remainder 1. And of course that's going to happen to every 100 block that we use here. So if I just carry out the same idea over here, I can see that I'll get a groups of size 3 here and here. 1, 2, 3. Just try to efficiently do this by coloring it similarly to the one to its left. So groups of size 3, groups of size 3. And again, I get the 1 left over there. So it appears to me that any time I have any number of hundreds, I'm going to have that many leftovers when I group by 3. So let's see what the situation is with tens. So with tens, what you'll notice is that you basically have to do what's happening here on the top row in the hundreds. You have to think in terms of small groups of size 3. Here's one of those. Here's another group of size 3. And of course, I'll just leave these open. Here's a third group of size 3. And there's one left over. And we can do this for each one of the rows, or I guess the rods of size 10. So let's go ahead and do that. Color them in. Oh, did I over? 1, 2, 3. Looks like I overcolored that one a little bit. Okay. There it is, groups of size 3. There are 1, 2, 3 in each one of these tens. And then we'll have these as leftovers. And we'll have these as leftovers as well. So I guess what this drawing is meant to show you, or this coloring is meant to show you, is that anytime you have a group of size 100, there's one left over. A group of size 10, there's one left over. A group of size 1, there's one left over. So really, to count the, to check to see if we really have something that's divisible by 3, what you can kind of think about is this these 200s, when I group by size 3, have exactly 2 leftovers. And this 5 tens, when I group of size 3, it has exactly 5 leftovers. And this group of size 8, when I count by 3s in each one of these rows, well, there are 0 3s and 1 leftover in each case, so there are 8 leftovers. So to check to see if this number is divisible by 3, all I have to do is ask this question, well, what is 2 plus 5 plus 8? Well, that is 13, 14, 15, so a total of 15. leftovers. Okay, so if I have 15 leftovers and I'm questioning whether or not the whole thing's divisible by 3, then these leftovers have to form groups of size 3. And indeed they do, and checking to see if they do is as easy as asking whether or not 3 divides 15, right? So here it is. So since 15 is equal to 3 times 5, the leftovers form an even, or I should say not even, the leftovers, how should I say this? Can be grouped into 5 more groups of 3. So that means the whole thing can be grouped into a certain number of groups of 3. So if it can be grouped into a certain numbers of groups of size 3, then obviously it's divisible by 3. So this would be an explanation of why the divisibility test for 3 works in the case of 258. But of course it's generalizable, right? I mean, there's nothing special about the fact that we had 2 groups of 100. We could have had 3 groups of 100. There would have been 3 leftovers here, right? There's nothing special about having 5 groups of 10. We could have had 8 groups of 10, and then there would have been 8 leftovers. And there's nothing special that we had 8 units. We could have had 3 units, and those would have been 3 leftovers. We'd go through this same analysis. We would simply count the leftovers and ask if the leftovers themselves form groups of size 3 when they're all put together. And since that amounts to simply adding the digits 2, 5, and 8, which tell us how many of each of these base 10 place values there are, we have basically presented a demonstration of why the divisibility test for 3 works. Okay, I'll make a scan of that and put that up with our materials for the lecture. Okay, let's move on and talk a little bit about the divisibility test for 9. Any counting number is divisible by 9 if and only if the sum of the digits of the whole number is divisible by 9. So this should look really similar to the divisibility test for 3 to you. Here it's if and only if the sum is divisible by 3. Here it is if and only if the sum of the digits is divisible by 9. So you should be able to think to yourself, well, how could I adjust this strategy, thinking about divisibility by 3, to think about divisibility by 9? So I'll let you think about that and play around with that by reading your text. But let's go ahead and just apply it to the list that we have and see if we can round this out a bit. So lucky for me, I wrote down all the sums over here on the left, and the ones that are divisible by 9 now will predict the numbers that are divisible by 9. So 234 is divisible not only by 3 but also by 9. I mean, just to give you a sense, if I take 234 and divide it by 9, I do get 26. So it seems like it did work in that case. 237, which we said was divisible by 3, is not divisible by 9 because 12 is not divisible by 9. Let's check it. And sure enough, I get a decimal fraction when I divide 237 by 9. So it is not divisible by 9. Let's see. Let's just go through the list and identify the ones that are divisible by 9. So certainly this one. 9 times 2 is 18. Let's see. Nothing up there. 3 is 27. Let's see. 10, 12, 30 is not a multiple of 9. Let's see, 15, 26, 8. Well, 9 is certainly a multiple of 9. And 27 is certainly a multiple of 9. 41, 42, 3. So it looks like only these three, which were also divisible by 3, are also divisible by 9. So this one, the 51,111 and the 81, 81, 81. Let's just check those just to make sure. 51,111 divided by 9, and sure enough we get 55,679, and then 818181, so 818,181. If I divide that by 9, I get 90,909. Okay, so it appears that those are the three from the candidates which were divisible by 3, which are also divisible by 9. Okay. Well, let's do the last one, divisibility test for 4, a little bit different than 9. It says that any counting number is divisible by 4 if and only if the last 2 digits of the whole number represent a number that's divisible by 4. So again, you're paying attention to only, similar to, I guess, 2 and 5 and 10, you're paying attention to only some subset of the number's decimal representation. And the last 2 digits are the ones that we pay attention to, whereas in 2, 5, and 10 we pay attention to the last or the units digits. So let's go ahead and apply that here and ask which of these numbers are divisible by 4. So I look at the last 2 digits and I ask if they're divisible by 4. So this number, the number formed by the last 2 digits, is 34. And since 34 is not a multiple of 4, this is not divisible by 4. 37 is not a multiple of 4, but 72 is. 4 does go into 72 18 times. So 72. 4 does divide 80, so 480 will be divisible by 4. I mean, just to make sure you're understanding, if we take 372 and divide it by 4, sure enough we get an even number. If I take 237 and divide it by 4, this should not go in evenly. No, it doesn't. So it does seem to be working. Let's go ahead. 45 is not divisible by 4. 78 is not divisible by 4. 95 is not divisible by 4. 77 is not divisible by 4, but 88 is. So that would be one of them. 11 not divisible by 4, but 16 is. Let's see, 25 not divisible by 4, but 0, 0 is divisible by 4. 4 goes into 0 times. Let's see, 21 is not, but 4 is. 4 is divisible by 4, goes in once. Let's see, 87 not divisible by 4. 45, 29, 10, 11. 81 not divisible by 4. 94, let's see, twice with 14 left over. Nope. 95 goes in twice with 15 left over. Nope. So it looks like there's only these 6 that are divisible by 4 in my list using the divisibility test for 4. You should really be thinking about to yourself when you conduct this test, well, why do I not have to pay attention to any of the digits that are to the left of 34? Or, I guess pick one here to the left of the 4 in the 5,304. Why is 300 and 5,000 not necessarily? Why do we not have to check those? That's the big question. And certainly, the strategy that we use for 2, 5, and 10 to explain those should be applicable here. In other words, there should be some argument that says that those digits are automatically divisible by 4 or form groups of size 4. So think about that a bit and do some reading in your text to see if you can solidify an explanation for 4. Okay, that's really all I had to share with you today, but I did want to try to reward those of you who watched the whole video and give you an extra challenge. So on the second page of the handout there is this question. Consider the interesting number below. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the digits as they go up here are digits taken from the counting numbers from 1 through 35, where it ends, 33, 34, 35. So this is an extremely long number, of course, too long to put into a calculator to check divisibility using trial division. So the question I have is, can you apply the divisibility test to this number to determine if it's divisible by 2, 3, 4, 5, 9, or 10? And explain how you know in each of those cases. And if you can present that here in a one-page explanation and hand that in on Wednesday when I'm back in class, then I'll add a point to your assessments across the semester. So the equivalent of moving, let's say, a proficient score 3 to an above proficient 4, or nearing proficient 2 to a proficient 3. So I'll add 1 point to your at the end of the semester if you can correctly and completely explain whether this interesting number is divisible by each of these 6 candidates: 2, 3, 4, 6, 9, and 10. Sorry, 2, 3, 4, 5, 9, and 10. I think that's all I have for you today. Hope you have a good weekend, and I'll see you on Wednesday when I return.